So first of all, welcome.
Yes.
Welcome to Open Data and AI Hackathon, from data to action. Woohoo!
Yeah.
We will be innovating, collaborating, and making a difference. You will see how. Okay, our mission, the mission of the hackathon. The Hudson Valley is drawing in data but starving for insights. The solution? Open Data and AI Hackathon. This one-day intensive hackathon is where government challenges meet tech innovation. Hello, government. We do have some government representatives here. They are hidden. You will find them later. Okay, we provide a platform for developers, students, and professionals to apply modern AI tools like Google Gemini, but not limited to real-world datasets, creating implementable civic solutions. Goals. Our goals from data to action. We're not limiting you to do whatever you want to do, but that's our goal. That's what we want to achieve. And we want to turn this data from silo to real actionable difference. To empower participants, you, to act as entrepreneurs. Because maybe, who knows, maybe you will start your own startup from there, like I did on my own. Well, not my own, but on the Google Hackathon. So I won there, and that's how Open Hub began. So we will show students how to apply open data and AI for creative problem solving, and we will create an inclusive, supportive space for personal exploration of strengths and weaknesses. Okay. So a little bit about Open Hub, the one I started, I believe, 8 years ago now. And actually, first ever Hudson Valley Tech Festival happened 2019. So we are now in 7 years doing the festivals here. That's why you're wearing the orange t-shirt, and you would be participating in this HV hackathon. So it's Hudson Valley Hackathon. Okay. I will not read all of that, but I just wanted to say since 2019, we were igniting entrepreneurial spirit and empowering with technology. So the goal is here, not only technology. The goal is also to unleash your creativity and do some craziness. And who knows, maybe it will be the future startup, as I said. But we will be solving civic problems.
So my name is John Sturman. I'm a lecturer here in computer science. But I'm also an organizer of a Google developer group. And this event is being brought to you partly by several Google developer groups, including Google Developer Group Hudson and GDG Capital Region, as well as the on-campus group, GDG On-Campus RPI. So we're really happy to bring all this to you. We hold regular meetings. So GDG Hudson and Capital Region were mostly merged at this point. We do 2 events every month. We do a web event and we do an in-person event. And we spread it around the Hudson Valley from Newbert all the way up to Troy. We may even go north from there. If you're interested in participating with us, please join. Go to these slides and click these links. Join us. We'd love to have you, and I see a lot of familiar faces. Nice to have you here. In the room we have Yulia, of course, Yulia Chinagova, who started Open Hub. Yay! We've got Heman Kola. Heman is a senior at RPI, graduating. A true workhorse and a force to be reckoned with. So just saying. For the GDG on campus, we've got Kyle, Sravan, and Kira. Stand up, you guys. Yep, thank you. They really put together a great program here at RPI for our students and for their club. You've got me. I'm a lecturer, and thank you. I've been working with Yulia doing GDG stuff for, I don't know, what's it been, 5-6 years? Yeah, a good long time, and I'm now finally growing into the position and happy about it. And then lastly, we have Rhoda Seraphim. Rhoda is Rhoda comes to us from Massachusetts. She's an I'm reading this, innovation strategist and ecosystem architect, professor, entrepreneur, professor, and business coach. She teaches at Harvard, right?
And Questrom at BU.
And where?
Boston University.
At BU, yes. And so we're really happy to have her as the MC for today. The last thing I want to do is I want to thank our sponsors. which includes Nice Tech. Where are the folks from Nice Tech? There they are in the back. We love them. They're awesome. We have Google developer groups. Google has also helped us with this, as well as Open Hub through Yulia, and then Arcos, the Rensselaer Center for Open Source. Let's give them a big hand.
All right. And with that, I'd like to introduce our keynote. He's a professional who's been working in open source for the past 25 years. In fact, he's one of RPI's own, directing the largest student-run open source initiative in the nation. I'd like to introduce Professor Wes Turner.
All right. So I was asked to give a talk to you, and I was asked to do a couple of things on it. First thing I was asked was to keep it brief. I was asked to make it fun. I was asked to make it inspirational, and I was asked to keep it brief. So I'm going to do my best. I think I've got the brief part down. 1 in 4 I can handle. We'll see if we can do the rest. What I want to focus on today is the fact that open data enables all of you to really actually make a difference. And I think that's the real part that's so great about this era. We are kind of in a point in time where the resources available to you guys are bigger than the resources available to the research institutes of even 2 decades ago or a decade ago. So this is really, we're back in the time of citizen science. I mean, you guys are here getting trained as engineers, but you don't have to be. And you don't have to be working in the fields that you think you have to be working in. So, my group, Arcos, Rensselaer Center for Open Source, we turned 20 this year. We've been around since 2006. And if you come back to campus over the next couple of months, hopefully you'll start seeing these logos around. This is our 20th anniversary logo. I've got a banner out there. I've got some stickers. They don't look like this yet. I've actually, if you want, you can get a tattoo or a temporary tattoo. Up to you. I would use it as a template and get it, put on your face or something. It'd be cool. Yeah. But we have temporary tattoos out there. We have this. This is the logo that's going to be coming out. So I'm really happy that we turned 20, and we are still going strong. As Heman says, we think we're the biggest open source student group, as far as we know, anywhere. But we're talking about open data. So there is a little bit of difference between open source and open data. Minuscule. Open source, we give you access to the source. It's yours. You can use it. You can do with it what you want. There are some licensing agreements on the outside, copyleft, where you have to re-release your software if you derive from it. But other than that, you're pretty much free to do whatever you want. Some open source licenses don't even have that restriction. If you look at open data, well, really indistinguishable. And that's a good thing, because right now we're in the era of AI. And if you know, AI is trained on data, and the algorithms are generally not all that complicated. They can get complicated, but the real secret and sauce comes from the data, and not having open data actually makes a big difference. When I was looking through this, I like to get my terms right at the start. This is the quote that I really liked, and it's from somebody who speaks British, not English. Open data is data that's available to everyone to access, use, and share. Yep, even your NAND. And I had to put that quote in there that it's grandma, because my wife didn't understand what this said. And she's my censor. But open data should be easy to access, especially for your NAND. So what we're in the era of is making data available, open, and easy to get to. And there's the citation for it. So I've been around a while. I worked for GE doing research actually in medical imaging, lung cancers in particular. So I want to jump on the Wayback Machine. Online, when I looked up open data, we're seeing 2007 as the inception date. That's not really when open data started. Open data started way before that. 2007 is when the government started saying, if we're paying for research, the data that comes out of it better be open. And that's when they started putting rules in place. So let's look at what it really started. And I'm going to use lung cancer as an example, because I was working in this area at that time. And there are some pros and cons to lung cancer. Well, there's cons to lung cancer. There are pros and cons to how we were approaching detecting and trying to solve for it. The pro is we were getting CT machines that could see increasingly small things. And, well, we know, as a general rule, the smaller you catch a cancer, the better your chance of extending the person's lifetime. I don't like to say cure. They call it, cure it, but extending the lifetime. Cons, well, if we're using CT, we're using radiation. Radiation causes cancer, right? So it's a catch-22. And both statements can be true. I believe both statements are true. But what we need data to tell us which one is more true. And can we come up with a protocol that actually helps extend people's lives rather than shorten patients' lives by giving them cancer? And it's not an easy problem. This cancer is easy to see. That's a cancer, right? These are lesions, and they're subtle lesions. This one, less subtle. This is a diffuse lesion. When you're looking at this, you have hundreds of stacks of images. A radiologist is seeing this in a stack of another 99 images. And what they're expected to do is go through and actually find this sitting there, detect it's a potential cancer, and then recommend some kind of treatment based on that. It's not an easy problem. This is a little better, but how can you tell this from this? This is a vessel moving through the lung. That is a cancer. Okay? It's not, again, an easy problem. So what's the current status? Or what's the status? Well, back in 2020, the 5-year survival rate, how long you live after being diagnosed, was only 15% of people made it 5 years. Okay? What's really scary about that is that it held steady for about 2 decades. So for 2 decades of a lot of investment and a lot of time, cancer rate had remained essentially unchanged. Diagnosis to death was generally less than 5 years. Today we've doubled that, just about, 28.1%, right? And what happened in these last 20 years? Well, it's this part, early detection and treatment options. And I'm going to go a little further. If we do early detection, this is for all lung cancers. If we focus on only the ones that we found via early detection, we're now up to 70 to 90%. Okay, now there are confounding factors. You catch it earlier, you got longer to live just in general. But controlling for all those factors, we've made a tremendous increase in your potential to live long and prosper with a detected lung cancer. And by the way, these are pretty close to the actual queries I typed in. I didn't fix survive instead of survive. This one I had so badly mangled that I did actually tweak the command. But if you enter these in, you'll get pretty close to these results. This is just, I think I was asking DuckDuckGo, whatever their engine is. So how did we get there? How did we get essentially double the survival rate, focused only on the accomplishments in a small subset of early detection in 20 years, 25 years? Well, back in 1999, 2 investigators, Claudia Henschke and Daniel Yankelevich, started something called LCAP. And it branched out to ILCAP, and then recently it's branched out to LCART. And what they started doing was they started using CT to look for subtle lesions, look for small things that haven't started yet. And they screened over 85,000 people. And this was pretty contentious because there were, on the con side, right, you're exposing these people to radiation. On the pro side, they're saying we can get 90%. They were saying 90, 95% 5-year survival rates. And that's stark, right? That's a big difference. So they developed a protocol where they're only screening people that are at high risk, people who have a lot of pack smoking years. So we limit the damage to people who essentially don't need it. They weren't the first people to study this, by the way. We had looked earlier at using X-ray screening and then fixed slice CT screening. And all of those had shown that radiation was bad. They were using low dose, very fine CT. Government got involved. 2003, they started a program called the LIDC, Lung Imaging Data Collection or something. I'm blanking on the C. Collaboration, 7 academic centers, 8 medical imaging companies. The whole idea was, instead of just having this one group do this, let's collect a bunch of data. And then in association with Ryder, started in 2004, let's get people to actually give us some ground truth, get some radiologists involved and telling us what they think that data says. All of this stuff came amid more and more pressure on the National Institutes of Health to revisit the idea that lung cancer screening was bad. And this, like I said, this was contentious. The people who were against screening were saying, we are killing people. And the people who were for screening were saying, we are killing people, right? And you can get very buried in that position. So this was very contentious. NLST started up over the years from 2002 to 2004. And I think that 2002 is actually, I think they're claiming 2002. I don't think it got actually running until about 2003, 2004 timeframe, at least full bore. But they managed to enroll 53,454 people. They had an established protocol based on what these guys had been doing for 5 years or so. And they started looking at the data. And you guys are too young to know this. Some of you, not so much. You were here during this. The NLST study was supposed to run for 10 years. The power to get a very, the more images you collect, the more discretion power you have to determine very small differences in protocol, right? You approximate more really what's happening in the world. This terminated at least 2 years early. And it terminated 2 years early because the benefits were overwhelming that lung cancer screening saves lives. So this is licensed CC by 3.0. That's an open source or open data license, Creative Commons. All of these are available publicly. You can get them. I've gotten the NLST data just by filling out a form and saying I'm doing some research. They're not necessarily the open data that we want to see. But remember, 2007 versus 2002, 2004, 1999. So for all practical purposes, this is the progenitor of open data. And it made a big difference. And it wasn't just, the big companies had a lot to say with it, but there were people working on this. There are people gathering the data, looking at detection protocols, because the more things small you detect, right, using computers, using AI, the higher the benefit is for the screening protocol. So right now we are in a golden time, right? And this is my original quote. Since 2007, governments around the world have increasingly embraced open data. And right now, if you get an NIH grant or you get an NSF grant and you're generating data, you are required to make it open, right? You have to submit it to a government archive. There are some, you can embargo it until you've gotten all your fame and fortune and papers out. But there's a fixed period. It has to be made open. It has to be made available. Open data is now routine. AI is everywhere. AI is doing a lot of this reading, not by itself. Radiologist reads. AI looks at it, says where they think there's a change. Radiologist reads again. Just the places that were in dispute. But that's everywhere now. And you guys have access to all of it, right? So I was asked for inspiration. This is my inspiration. These guys were they're world famous radiologists at this point, but they were just radiologists that had an idea on how they could stop lung cancer. They were working for Cornell Wheel at the time. The beauty of open data is that anything that's out there that is open, you can get. You can solve your own problems. You can get to the stuff that you're concerned about. You can actually make a big difference. And you can do it sitting on your couch, in your pajamas, eating pizza. Or you can come to the office and toss on a jacket. It's up to you. I also want to throw out this guy. This guy I worked with, this is Rick Avila. I worked with him a lot of times. He was really close associates of Claudia and David Yankelevich. He's here. not at RPI. He's in this area. He's up in Clifton Park. He runs a small company, Paraxial. They use this open data to try to improve CT scanning, automated detection, and calibration of CT systems. So he's still working in this area. He's still here, and he isn't Claudia Henschke or David Diankalovich. There's a lot of places where you can contribute. So hopefully, there we go. That was it. So thank you. I hope we solved cancer here. But if not, let's solve methane pollution or whatever else the topic of the day is. Thank you so much.
I'm just going to give the resources that Professor Turner was mentioning about. So if you guys want to take a photo of this, that tiny URL, and the QR code that leads to it will take you to a spreadsheet with all of the open data resources that we have available, compiled into one nice list for you guys. Some of them require you to fill out a form saying that you're researching, like Professor Turner just mentioned, so be aware of that. But these are all open resources for you guys to use in your projects. With that, I'm going to hand it off to Rhoda to start our challenges.
I just want to tell you a little bit about me in the sense of why am I here and why do I come to these things? So I have a strength and a weakness, and that is I believe in people. Sometimes that's a really good thing and it works really well. For example, this past week, one of my startups just raised $3 million and they're not even 12 months old. So I'm very proud of them and I'm very excited. But what gets me really excited is that you really can change the world. We've just heard Professor West talk about it, but I know that. Do you know that? Can you change the world? I can't hear you. Thank you. Thank you very much. Okay, so we're here today to take the opportunity and learn about the challenges that we have more locally to have civic tech and open AI work together to create real results and real change in our local world and perhaps further away. So before we get any further, I will introduce you to some of the themes that we'll be working on today. Okay, so have a close look at what we're looking at and see perhaps where you might fit. Is it that? Okay, so we have two major ones, okay, in the community. We have some issues with adult education, transportation access. Some of those issues have to do with people want to get educated, but they can't get there, or they think that they can get there and they sign up and they can't. So there are some of the chicken and the egg issues. There are maybe some people here who know more about the local situations that can help you understand the problems better, but that's one. But there's plenty of data, okay? I always say we always have more resources than we use, okay? That's always the case no matter what, even if you're hungry. Okay, we just have to figure out what to do with it. Okay, and that's one case. We have plenty of data ready. We have clear scope and deliverables. We have immediate policy relevance. Okay, people sometimes complain, oh, the civic stuff is hard to do because it takes forever to roll through. Well, not this one. Okay, we have plenty of support. It's accessible to college students and it demonstrates civic tech impact. Okay, that's a different thing. When you're starting to work on problems that are directed toward your community, toward your city, toward your neighbors, you can see your own impact so close. It's like you're not just helping yourself and your family, you're helping your neighbors and the people around you. Okay, that's another form of impact that makes you a good citizen too. All right. On the childcare access optimization side, we have it's a bit more of a higher complexity. We have some economic modeling to showcase, and it directly relates to workforce development focus, which again relates to the adult education transportation. If I don't get educated, or if I can't get educated because I don't have transportation, how do I cater for my children? Or maybe my children are growing up and they need to get educated and they need to go places. So those problems kind of do connect together, and you get some better ideas of the local problems with some of the locals that are here in a little bit. And then let me tell you about this. Okay, so we have some prizes that you can get by providing some solutions for us today. Some of them are in money, right? In money form, which are first place, $500, the gift card, second place, $250, and third place, $150. But let's look very closely at the in-kind opportunities, okay, guys? Because we need to think more long-term. I'm a strategist, so real project implementation. winning teams can get contracts to build their real product in real life to impact. Okay, so you can do that today. So remember that. All right. Leadership interviews. You can get access to the DCC administration, county officials that are hiding here. Okay, and get connected to the leadership of the towns and places right here today. Internship opportunities, right? Fast track interviews with Open Hub and instructor regional employers. Conference presentation opportunities, and also ongoing consultation. Imagine you get a paid consultation to implement a solution. So we have a lot of real practical problems and issues, plenty of really good open data. Hope you all scan that QR code, open data to do it. And we have some very practical return for you. So if you think of the ROI here, which ones are best? I think there's quite a few ones in there. Okay, so I hope you find a few of these quite appealing, because honestly, there's a lot of value on this list. Okay, and now we move on to the demo.
Again, my name is Roman. I am a Flutter GDE. I am also a lead organizer at GDG Lawrence. That's actually 2.5 hours away from here, but I love the fact that I can collaborate with other nearby communities like GDG Hudson, GDG Capital Region, and other communities. I am also a cloud architect. I also, build applications. I'm a software engineer at Philips Health Systems. I like to help the community and build stuff together. So I'm so glad to be here to not only inspire you, but also to help you shape your ideas. Whatever you guys are thinking about building for this hackathon, we're gonna I'm gonna help you make it happen. Awesome. So let me just show you a couple of things here. So awesome. So we're here. Awesome. You can see it right there. Yes. So the reason why we're here today is because we want to start building, with open data. We want to use AI to build meaningful applications, for the community. We're all here again, not only because New York has like a bunch of data that is like untapped. There's a lot of amount of open data in the form of JSON, Express sheets, and all of that, and nobody has been able to like tap into that and truly make like more meaningful applications for the community. There's a bunch of government agencies that provide this data, but they're waiting for folks like us to tap into that and then build amazing applications with it. So the theme of today's hackathon is from data to action. And again, to the tech community, this is not just for you to build your resume or start building applications, but this is more to, you pick a problem and you want to solve it, and then you use technology in your favor to do that. And for those municipal partners and community leads from here, you bring your challenges, and we bring the genius, and then we rally around it and solve those problems in the community. So I just wanted to show you real quick that in a matter of 1 hour, I was able to build 2 applications using public data from New York. Because again, the team came up to me and said, it'd be great if we could build something. And I'm like, sure. I'm gonna show you now how, if you say, okay, can I build something by the end of the day? Yes, you can. I was able to build 2 things in a matter of 1 hour, just using the tooling and exactly those same tools. I'm going to be sharing those with you. So the first one is called Career Pivot. You can actually even scan the QR code, and that is publicly available because I created it with Google, with Gemini, and then I was able to publish it. So Career Pivot, what it does is using the data sets from the long-term industry projections. And what it does is it's a life wage matcher and career growth analyzer that integrates directly with New York State's open data APIs. And what it does is it checks like the wage statistics, long-term industry projections in real time. It tells you, given, for example, let's say one career, how much you're going to be earning, how much, let's say as an entry level, let's say if you want to get into that career as an entry level, let's say a professional, how much you're going to earn in the mean, and how much if you become like an expert. And it also tells you regions in the around the region where like you can get the most money, and also, for example, like how you can like upskill in that front. So let me show you the actual application. I have it right here, and then you guys can, for example, like tell me what to do. So I'm gonna share right here. So give me you can shout it. You can just give me a profession, any profession. Data engineer. Let's do that. If I type data engineer, it's gonna tell me around the area how much a data engineer is valued how much you're gonna earn as an entry level, what is the mean salary, and also what is the salary, let's say, for an expert. So it's using all the data endpoints that are right now readily available, and you should get affect that information. It's gonna give me like charts. It's gonna give me like a nice report, and then it's gonna present it to me. I know that I have like a little bit of a slow Wi-Fi right now, but at least trust me, if you guys have a better Wi-Fi, you're gonna get it right away on your phone. So if you scan the QR code, you should be able to get it much better than me. But this is gonna generate a report like the one that I showed you back here. Let me show you. Yeah, yeah. So the Wi-Fi, my Wi-Fi is not too good here. It's this one, the RP Public Web Auth.
Oh, yeah.
Yeah.
Try update on certain end, right? Could do. Yeah, they still working there.
Okay.
I work.
But anyway, you will see it like that. It will show you like a graph, tells you for that, for even let's say for regions like Capital Region, New York City, Hudson Valley, it tells you how much that career is valued, how which other steps you can take to upscale your career, and how much money you can make. All of this data was actually created. All the data is readily available. In that application, I didn't even lay a single line of code. So if you guys have a better network than me, you can just scan the QR code, type that same profession, and then you're gonna get that one. Let me show you the next application that I built. Again, all in a matter of 1 hour. The next one is called Eco Scout. I wanted to show how, let's say, in any given region, how if there are, for example, like solar power incentives around that area, how that particular area, let's say, is ranked as far as like eco-friendliness. If there are like electrification around it, as far as like EV charging stations, solar power incentives, and whatnot. And the same thing with this one. I have the application right here. I hope this time maybe this might work. So the same thing with this one, and I even created it using, again, not a single line of code. I was able just to provide it with the prompt. I gave it the data APIs, and then I was just massaging the prompts little by little. Here, for example, let me see if this one works. If I type, for example, I used to live in New York City, so I used to live in Washington Heights, 10031. Let's see if this one works. Again, it's just the Wi-Fi, but if you scan the QR code, you will be able to get that one. So this one will give you, if it's not gonna come up, that's okay. So it gives you a map. It tells you the area where you plug it in. It tells you if there are like EV charging stations around the area, but it tells you with three concrete goals that you can do in your community to qualify for maybe like solar power grants and make your area eco-friendly. Like I said, I didn't even have to like do any coding whatsoever, even though I am a senior software engineer by trade. But it was pretty comforting that a lot of people come up to me and say, but I don't know any coding whatsoever. Can I be part of this hackathon? Yes, you can. And the reason why is because Google Gemini has democratized the way that we can build applications and create. All you need to be is passionate about it, have a great idea, you want to solve a problem in the community, and all of that has actually leveled the playing field. So now, yes. So now, what is the recipe for success? So again, right here, you see, you want to find out the why. You want to see what is it that you're trying to solve. What type of problem is it that you want to solve? You also want to use the Soda API. The Soda API, I can show you how to use it, but it's all available in the spreadsheets that the team put together. You just have to find the correct API that outputs the right data, and then you can feed it into the LLMs. That is the Soda API. I'm going to show you like winning prompts. Like immediately you can just have a template prompt that you can use to start your application right away. So you need to know that in order to perform like, get the perfect. Okay, so, but we're going to have to switch it to this one then.
That's fine. There's a button on that panel there. Just HTML, PC.
Perfect. Let's try. Type 10031. That is where I used to live in New York.
10301.
10-0, one more zero, and then 3-1. Hit enter.
This is good internet, just saying.
Yeah, perfect. There it is. See, it rates at a 4 out of 10, and then it tells me, for example, like what are charging stations around it. Now put the zip code of here of the RPI, which I think is 12180. Perfect. So Manhattan was rated out of 4. Let's see how this area rates as particular like in around like solar trends, EV infrastructure and whatnot. 7 out of 10. That's pretty good. So you see, and that's exactly what I was trying to show here. So you can build all of these applications very easily with very little effort. I just wanted to show you now what would be a winning. Which one now?
What HDMI? Or no, what do you
Flip this one.
USB through the bottom end.
Present. And then here, just to wrap it up, guys, let me just show you what you could use to build these applications right now without, if you don't know any coding, even better. If you have an idea, then you're going to be able to give it more shape. So you could use AI Studio, like I mentioned. AI Studio is this web-based rapid prototyping platform that you can use to build your applications. We're going to set you up with Google Cloud. We're going to give you, I'm pretty sure we're going to set it up with cloud credits. Perfect. So we're going to try to set you up with that. But if you use AI Studio and you used a prompt like that where you say, I want to build an app that solves, and then you plug in your challenge. You say, I want the app to accomplish this particular goal. You want the app to work as follows. You provide the kind of like the bullet points of what you want your application to do. Then you say, use the following APIs. You plug in the APIs. Then the rest are just like stuff that you want to make it more usable, more user-friendly. You want to maybe make it more secure. Because then after that, I kid you not, you don't need to implement like SSL. You don't have to spend time on that. You don't need to create a database because AI Studio will create it for you. You don't have to implement authentication because it will create it also for you. And you could even collect user data from it to make more intelligent decisions. So again, with that being said, with all of these tools at your disposal, there's no reason why at the end of this hackathon, you may not even have like 3 or 4 apps already created. So that's what I'm expecting from everyone, at a minimum one. But at least with this prompt, if you feed it into AI Studio, you can start building applications right now. No coding whatsoever. What we're trying to do here is solve problems that help the community as a whole. So with that being said, thank you so much, everybody. Please hack away. Find the orange t-shirts. We're going to be helping you guys out, and good luck to everybody. Okay. Thank you so much.
Thank you, Roman. We are proud to have him. And actually, he's around, so he would be circulating between teams and make sure you grab some of his brain. Okay? Thank you, Roman, again. Let's talk logistics a little bit. Time is running, so we are going to hack at 11. So hopefully we will get into this really quick. So first of all, this is something like community agreement. We all have to agree that we are here supporting each other. While we're competing, we still will practice inclusive practices. We will teach and model inclusivity for ensuring that all team members have the opportunity to contribute. So actually, we will call you to form teams out of 5, no more than 5, right? It's okay to have team of 1, which is not very okay because we want to show how the power of teamwork.
If you're one person, it's much harder to collaborate.
Yep. So it probably will be judged against that. Anyway, so teamwork would be judged as the barometer. So we do encourage you to include more people, and you need some diversity because you need different thinking, you need different role, you need product manager, project manager, you need data scientist, you need user experience person, you need designer and such. So we will encourage innovation and creativity. We want to see how your creativity is shining, and that's what we will be actually facilitating here, circulating and challenging you, and you will be challenging yourself and others instead of challenge until you have it beautiful. I bet you will be proud by what you will build. In the time constraints given, I know it's really quick hackathon. You're not used to that, but let's do it dirty, but straight to the point. And valuing diversity again, help teams understand the value and diversity of the talents, skills, and perspectives. So that's my call to action to everyone, saying that, Rhoda, would you join me here? She will pick from me, and then you will see our team coming again and again in different roles. displayed. We are just performing teamwork right now, right here. You see all of us moving and shaking. That's what we want to see at your final presentations.
All right, so let's keep the housekeeping going on. Okay, so what do we got next? Let's revise our schedule for a second just to see how the day's gonna go. We got plenty planned for you. So we are almost at the time that we're going to be pitching. And we're going to go from about 11, right? And then we're gonna have mentoring assignment mentors around the room. Just when the teams come to pitch, please listen to their ideas and pay attention so that you can then assign yourselves a team to work with. We are going to have mentors working with specific teams throughout. Of course, if anyone needs to change, that's fine. And you also are going to have plenty of support. Myself, I'm also a mentor, a business strategist, and we're going to have plenty of people around. So how does the hacking work? Okay. So the teams are going to come up. You're going to come up with your idea and you're going to come up and pitch. Your pitch must be 60 seconds, no longer. Okay? We're going to have a timer somewhere, but no longer than 60 seconds. Okay? I'll give you some directions and some support here to help you figure out how to do that in 60 seconds. Then we're going to form our teams, and then the mentors are going to pick their teams, and then you're going to hack away for most of the day. Okay?
Do you have idea for your potential startup, for your solution? Are you ready to pitch? If so, please start lining up here because we will give you the mic. Okay?
Okay. So I guess
Just
we're calling
like
them.
the first one. And behind me, please come over if you had an idea. Rough idea is okay. 60 seconds, just pitch your idea and see if it will stick.
Okay, guys. So let's get some other ground rules going here before we start the pitching. So you have a few minutes to start thinking about what problem you want to work on. Okay, and extremely important. Yes, I already said it's 60 seconds. Fine, it's the classic. Now, I think I would focus a little more on the orange side to stay focused, okay? In your 60-second, you must answer 3 basic questions. The first one is why, okay? If you don't have me hooked on the first line, it's gone, okay? Why is that? Okay, give me a good reason to listen to you. Give me a good reason to support you, okay? I mean, I do it anyway, but you need to sell me a little bit, okay? So when you answer why, you're going to already automatically state the problem and also give a little context, sort of such as like a little bit of a storytelling. And I'm not talking about a long story, okay? It's 60 seconds, so this is not going to be like 10 lines, all right? The whole thing. What, right? In this order, right? What is your solution? You are definitely already very familiar with plenty of solutions that you know how to produce already. But how to take the solution and address a problem is an art, okay? So what is a pitch or what is a value proposition? A value proposition is the combination of a very clear problem and a very clear solution that turn into a benefit. This benefit then turns into an ROI, but I cannot have any ROI unless I have this problem and solution give me a benefit first. What do I get with it? I'm solving this problem. This is the solution. This is what I get. Remember? Okay, this is very algebraic if you think about it. Okay? So keep yourselves focused on that and make sure you answer that question right at the very beginning. You got 60 seconds. Okay? And at the end, yes. The what should be at the end, actually. Sorry. Yeah, it's flipped. Sorry. It's why, how, and what. Okay? So basically, problem and reason. How you're going to do it, it's your solution. And what? Who are you? Why? What are you? Who are you? Introduce yourself. Remind me. Why should I listen to you? Okay? So give it like a little short. So a little bit deeper into, so I'm going to go through the rubric here and we will summarize it at the end just to remind you. But there are 8 topics that you need to make sure you cover, okay, in order to fulfill the judge's criteria. First one is problem and validation. So we talked a little bit about value proposition, right? Are you solving a real problem? What does that mean? The solution, guys, is at least 50% the problem, okay? So if you can state your problem really well, you already should be able to be thinking of what the solution should be, and vice versa. Okay, just make sure those things are tight. Is your idea unique? How is it different from what is already there? Right? Did you research or open data to validate it? Let us know. How did you identify a specific target market? If I don't have a customer, again, I also don't have a value proposition. If you don't have a value proposition, you can't sell. Okay? Okay. Now, as far as the use of the open data, make sure that you do use the open data. That's why we're here today. And then there are some specific questions that we want you to answer with that. Okay? What specific queries did you use? Like some of the most important ones, right? Maybe some real central question that you asked. Okay? The next one is value and impact. Okay, what value does it have? Again, when you have that value proposition, if you have value, it'll show itself, especially in impact. If you have a problem that combines with a solution that gives you a benefit, how does that then impact the community? How is that become even more valuable so that we can have ROI? And ROI can take different forms, okay? Presentation and teamwork, extremely important. Make sure you work in a team. Make sure that more than one person speaks. Make sure that when you are choosing your teams, you have different skills or that you can leverage off of each other. Okay, this is extremely important. Teams, not having a team is the number 2 reason why 95% of startups fail. Okay, use of AI. Did you use AI in your solution? Hopefully. And also include the specific LLMs that you used. Okay, tell us exactly. I hear all the time, oh, we used AI or we used this. Give us a little bit more. Be more specific. Okay. And then how you demonstrate, right? How do you talk about it? Did you actually run home with your solution? Did we understand your solution to solve that problem? Okay, just try to be as clear as you can, as concise as you can. Okay. Team collaboration, we kind of covered that already. It's extremely important. And then future plans. How do you plan on moving forward from today? Okay, you got a hook, you got a pitch, you got a hook, you got some value to propose. Now what do we do from here on? Okay, so 8 criteria. Just to remind you, again, there they are. I will leave them on here as you hack away. But there's eight criteria. Okay. Was someone else gonna come to a lot about this? Okay.
In terms of your team building, you do definitely want to make sure that you're all unified. You want to be working together. So, set realistic, achievable goals together, but it's goals that you can achieve. Don't, shoot for the moon. I mean, the moon's fine if you want to go there with the Artemis too, right? But you put together something that you think you can put together today. Manage your time. But there's the idea of divide and conquer. So if you have a team of 5 people, you don't all have to be focused on the same thing, of course. So, but plan out your time. We're doing presentations at final presentations at 4. It's you'll get started sometime around 11:15. So just make sure you work out your time. And then lastly is scope. Set up your scope. What I suggest is you set your scope too big and then scale it back as you go, as you need. But having more ideas than less is better. Having more ideas means you can pick and choose between your ideas to fit in the time that you have. And then you're forming teams. So let's
Leave the
pitch.
Yes. All right. So, have you guys thought of some ideas that you might want to sell and build a team around? Do we need another 5 minutes? What do we think? You got a pitch, right? We already ready? Okay. So if you're gonna pitch, come on up. Let's line up over here. It's pitch time. Let's go. Okay.
I just want to say,
Absolutely.
I want to say real quick, I'm a data engineer. And so as you're thinking about what your ideas are, you can think of them in sort of 4 categories. Okay. One is data visualization. We already saw a couple examples of cool dashboards that Roman put together. So that's one thing that you can do with data. You can do data transformation. So you might take 2 data sets and combine them together, do some some math or some reshaping to correlate them with each other, and then create a new data set, a new open data set, and then put it on Hugging Face or something so that other people can use the data set that you changed. Maybe you've done classification with AI on the data in order to produce some annotated data, and that could be really useful to other researchers. So that's something you can do. You can do data serving. So you might create an API that is then, providing data to other people. And you can do data connectivity. And that's where you take the data and you plug it into some other service that does something in the world. So maybe you have like your robot and you're putting GIS data into the robot so the robot can navigate. That would be an example of, data connectivity. And I have no idea, honestly, what you could connect these data sets to because I haven't look closely at what kind of data is available here, but if you've got some other service that you can push the data into to get something done, that would be a really cool application. So think in terms of those 4 categories.
Okay, pitchers. We need pitchers to come up here and line up, guys. If you're gonna pitch an idea, please come on up.
Hi everyone, my name is Yusuf Song. The problem I want to solve is public transport. So one thing, I worked at Walmart a while back and I live in a suburban area. And one thing I saw is a lot of people take cabs because they don't have cars or have to use public transportation. And one way maybe that we could solve that problem is creating like an application where you can crowd source some data where they have specific paths, maybe through biking or walking on trails to a different location. And then maybe other users can give a rating on how safe it is and how easy it is to cross that path. So hopefully with the team, I'm mainly a coder and I like working on the back end. I'm definitely down to do some front end, but if anybody's interested in working this project with me, let me know. Yeah, got it. All right.
Good job. Excellent assignment. Excellent. We got 20-second pause, okay?
Hi, everyone. My name is Bryce. I'm an electrical engineer at the New York State Education Department. I'm basically a home inspector for schools all over New York State. And the problem that I want to address is we don't use AI in what we do. So I think it would be nice to make an app that uses AI for home inspections. This would be good for, students looking for student housing, people looking to buy their own first home or new home, but being able to not pay, $300, $500, $600 for a home inspection, just for, a first go through to see if there's any really big problems with an apartment or a home. And I plan on doing this heavily relying on AI for a lot of the code. I've dabbled in full stack in the past. And if we can also find data sets to help us solve this problem.
Hi, everyone. My name is Luke. I'm actually from Minnesota, so I need help with 2 things. One is somebody who's more familiar with the area here to help map out some locations that might be good to target. But 2, I need somebody that might have a laptop because I'm going to do this from my phone. The problem that I want to try to solve is what's called a childcare desert. It basically means that there's a lack of childcare resources available for parents to use to send their kids to. With people going back to work, more return to office, and multiple parents having kids that they need to send to daycare, there's a lack of resources. There is a database that's out there. They can look at it, but it doesn't cross-reference any sort of Google business reviews. You have to individually look those up. So it looks like most of the data is readily available. We can cross-reference it. We can build a map with hotspots, use US Census availability, tracking data on children under a certain age, and then hopefully put that together. Look forward to work with you guys.
Hi, my name is Ahona Mukherjee. I am a UX designer and researcher. I am hoping to solve the problem of accessible public transportation in New York State. We do have a robust public transportation system. If you look at the newyorktransit.org, we do have public bus transportation all over New York State. However, many people do not know about this system. I want to be able to make an app that is publicly readily available for all people, especially for people that do not know this exists, and also combine this with maybe wage statistics and also if these tickets pricing are able to be within budget as well. So combining both accessibility in terms of wage so people can get to their jobs, education, classes, etc., whatever they need to get, as well as knowing exactly where this transportation is. So designers, computer engineers, etc., if you would like to be on my team, please let me know. Thank you.
Hi. My name's Matthew, and one of the main problems I'd like to try and solve is public transportation deserts because for or the most part when I'm walking around in Troy at the very least, it's like I don't really know where anything is. It's like I have to run around and search for them. It's just kind of annoying. And it's also the fact that s- for lower income communities as well, it's also just not great because if you're forced to get a car, it's like you're gonna be in debt for the most time. And like gas is expensive nowadays. So my idea is we will pull up the data from New York State and find and use it on like road conditions or maybe like bus lines, train inlines, bike lanes and stuff. We'll find areas where it's lacking and simply give suggestions on where to put it. And
My name is Aryan. I'm a new graduate in computer science from Penn State, and the problem I want to solve is to essentially, I feel like planning a bird watching trip is pretty complicated, as it can be pretty complicated because you have to uh, kind of keep track of different sightings and the seasonality and the location, and you often don't know what birds you want to see. And the solution is to basically build a web app and hopefully a mobile app as well, and use the Cornell eBird data to um, essentially provide the users a solution where they can plan a bird watching trip very easily, and essentially show the user exactly what birds they can see, how convenient it is, and how feasible it is. And that's what we're trying to do today. That's basically my idea.
Hi, I'm Brian. I'm a IT professional. I live in the city of Poughkeepsie. So the problem that I see in that city is that the housing vulnerability and preventing neighborhood blight. So the solution is a data-driven neighborhood health predictor dashboard that flags at-risk properties before they decay. To do this, you need to access the Dutchess County property data sets and foiled code violations, plus a team skilled in GIS and spatial data analysis. Um, yeah, the city just really hasn't weathered deindustrialization well, so there's just blight everywhere, and like there's good parts and there's bad parts, but I think if you could um, kind of map it out on a web app, that would help a lot of people that live there.
hello, my name is Matthew Voinovich. The problem that I'm aiming to solve is that on job sites, for example, there's a lot of times that gas leaks or other hazards will go undetected because they're invisible to the eye and may not have a smell. So the solution that we're thinking of is to use something like an Arduino that we can apply a classification model on to learn what certain gases are to detect these hazards. And then that would combine with New York State open data, that is data on like spill incidents or other hazards, and integrate it into a dashboard that can help automatically detect these hazards and classify them into certain types so that job sites don't end up missing these kinds of things.
Hello, I'm Keshav. One problem that exists in a lot of more rural areas is people don't have very widespread access to broadband internet. So, especially now that we're placing these small 5G towers all over upstate New York and in other locations, for people who are increasingly engaging in online learning and online classes and certification programs, having unstable internet access can mean or be the difference between you finishing your degree or not being able to get your certification and then move on with your career. So, one thing that exists right now that's a major problem for policymakers is that there's not a lot of data that correlates, where these internet towers actually are. And all the different ISPs have different amounts of data and coverage, and their coverage maps are often kind of bad or over exaggerated. And so there's a lot of different very disparate data sets out there that exist that describe where actually these broadband internet access points are. And so if you can aggregate all of them, you can provide a very powerful tool for policymakers to figure out where we should develop our future of internet technology.
My name is Shravan. I'm a computer science and IT. Uh, Mostly like I don't know. I like learning about like diseases and how we manage them and stuff. Yeah. So my idea was I wanted to use the New York State. This is like a relatively small scope because I'd like to, I don't know, keep the ideas like, I don't know. I want the ideas to be more annotated by the team around it. But I was thinking I'd use the New York State statewide COVID-19 testing data that's been like kind of stratified over counties to build a data visualization to try and map like sort of geospatially how does COVID sort of spread between communities, especially since it's so like 5 seconds. Yeah. So that's pretty much it. If anyone wants to build a cool visual that changes over time.
I'm Corey. I'm trying to solve adult education transit accessibility through analysis. I'm pitching so that I can pitch afterwards. The school problem, and I've only just started looking at it, so I don't know specifics. Yes.
He believes there is educational problem. We don't know which one yet.
Hey everyone, my name's Drew. So we're trying to bring people from low income areas to the schools so that because like a lot of times there might not be bus routes and things like that to get people to like community college, vocational schools or whatever. And like for example, if you're coming in from like Mechanicville to get to like Hudson Valley because you want to go to the automotive industry or like to learn about cars, it's quite a hike to get up there. So what we're trying to do is we're trying to get the bus route, like get more efficient bus routes for city planning to get people to the proper schools that they want to go to. And so we already have some people that do AI stuff. I'm a full stack developer, and we're probably trying to get some more AI engineers.
My name is Rayana Men, and the problem I want to solve is finding good education services that fit your criteria. Because nowadays, there's a lot of uh, demographics that we want to consider. So using a data set that schools the all demographics for them, their classes they offer, their locations. We're gonna use all that, and we're gonna help filter out and show schools that would be helpful for whatever you want it for. And to do that, we mainly just want like people who know how to use the full stack development. Let's rock this afternoon.
My name is Alyssa, and this is Hasani. And we're really passionate specifically about how healthcare works. A lot of times in the United States, healthcare can be very reactive. So a lot of like prescriptions and drugs and things like that. But we want to focus on what are the root causes of these things. So like lack of access to proper nutrition, Medicaid, how that's distributed, and a bunch of other things that cause healthcare to act like this certain way. And then
Yeah, so rather than like taking a reactive approach, like looking at the root causes and more preventative approach. But okay, so like taking a more like preventative approach to the problem. So we're not really sure exactly what data sets we might want to use, but we're looking at like more environmental factors or access to food, access to reliable transportation, clean water, things like that. And hopefully like this can be something that governments or other like nonprofits can use to inform policy and future legislation to identify the existing gaps. Yeah, so if you want to work with us, mentor us.
I have another traffic related one. I guess every year a lot of small towns use a lot of residents to preventable traffic crashes. So the idea is to build a map that combines 3 public New York State databases, crash reports, average daily traffic volumes, and 311 road condition complaints to surface dangerous locations. And so, yeah, we're going to highlight these areas so that people can act preventatively and fix problem areas on the roads before accidents happen.
Oh, excellent. Thank you. Thank you. Make a poster. Okay, time to recruit for them. So they're going to convince you. Go interview them. Go talk to them and form the team. Okay? In group around your poster, you have 5 more minutes to interview them and pick your team.